Roughly 13.75 billion years ago, our universe came into existence. Very shortly thereafter, primordial light started shooting across the cosmos and spreading throughout the early universe. At this juncture, the universe itself was also expanding. The inflation of the universe slowed after the first initial burst, but since then, the rate of expansion has been steadily increasing due to the influence of dark energy. In essence, the universe has expanded at an ever-increasing rate since it first began. The earliest photons that humans can detect, according to cosmologists, have traveled 45 to 47 billion light-years since the Big Bang. Therefore, the size of our visible universe is around 93 billion light-years. All of the quarks, quasars, stars, planets, nebulae, black holes, and everything else that we might potentially view are contained inside these 93 or so billion light-years. Yet, the observable universe only includes the light that has had enough time to reach us. If the universe is just 13.8 billion years old, how can it be 93 billion light-years across? That distance hasn't been covered by light in time. The answer to the question of whether humans might ever go beyond the boundary of the observable universe and what lies beyond is ultimately found in knowing this aspect of physics. To explain, special relativity states that things cannot move faster than the speed of light when they are near one another, but that this restriction does not apply to objects that are very far off from one another while the distance between them is expanding. The distance between items is growing, which causes them to fly away from one another at incredible rates, not that objects are moving faster than the speed of light. This ultimately means that we could only reach the edge of the observable universe if we devise a means of transportation that enables us to 1. Travel faster than the speed of light, which most physicists believe to be impossible, or 2. Transcend space-time by using wormholes or warp drive, which most physicists also believe to be impossible. The size of the whole universe is at least 1023 times bigger than the size of the observable cosmos, according to the cosmic inflation theory. We are losing out on a large portion of the cosmos. What precisely are we lacking then? What exists beyond the known universe? Unfortunately, we have no idea what is outside the observable world because we can't see it or measure it. However, there are a number of hypotheses that explain what is beyond the immense unknown. This initial concept is one of the simplest to understand despite its weirdness. According to astronomers, the universe beyond what can be seen may be a limitless expanse of matter that is distributed nearly identically to that of the visible universe. This makes sense. After all, it is illogical for one region of the cosmos to differ from what we observe in our surroundings. And who can imagine a cosmos with an end, with a big brick wall waiting at its edge? Infinity therefore makes sense in certain respects. However, the concept of infinity implies that there is more matter than only planets, stars, and other visible objects. You'll ultimately come across everything. Every single possibility. That implies that, if this is accurate, and we follow it to its logical conclusion, there is someone else out there who is exactly like you in every way imaginable, as well as a version of yourself who is only marginally different from you in every way imaginable. One is an inch shorter, one was killed by a bus 5 years ago, one is missing a finger, etc. The only difference between you and this other you is that they just picked their nose while you didn't, or did you? And this other you may even be reading this article right now. This idea appears incomprehensible, but it's also difficult to imagine infinity. The subject of another notion is something termed dark flow. Galactic clusters were all moving at an incredible pace of more than 2 million miles per hour in the same direction in 2008, which was a very weird and surprising discovery for astronomers. Massive structures outside the observable universe that are affected by gravity are one potential source. As for the structures themselves, they may be anything from weird space-time warps that are channeling gravitational forces from other universes to astonishingly enormous accumulations of matter and energy on proportions we can scarcely comprehend. Simply put, we have no idea what these enormous objects may be. Notably, subsequent assessments have asserted that the dark flow hypothesis is unfounded. But this assertion is still under debate. World of universes is an additional possibility. Some theorize that the entire cosmos may be contained in a tiny bubble in the middle of an enormous number of other bubbles. Physicists refer to this as a multiverse. The theory, which is intriguing, claims that these parallel worlds might interact with one another. Gravity can move between them, and when it does, a Big Bang similar to the one that produced our universe may take place. Of course, it seems implausible that there could be a limited world with no space outside of it. Not even nothing in the sense of an undefined, utterly undefined object in mathematics. In actuality, asking what's beyond the universe is like to asking what sound does purple make. Because you're attempting to mix two unrelated concepts, your query is absurd. There is a very real possibility that our cosmos has an outside. Again, though, it need not be the case. There is nothing in mathematics that necessitates an outside to describe the cosmos. Don't worry if everything sounds difficult and confused. The goal of creating complex mathematics is to provide us with the tools necessary to understand ideas that are beyond our comprehension. One of the benefits of contemporary cosmology is that it enables us to investigate the unthinkable.